Human ambition has always pushed beyond what was once considered impossible. Across the world, massive megastructures are rising, challenging gravity, materials, and conventional logic. These projects are the result of advanced engineering, artificial intelligence, and decades of research that turn unrealistic ideas into physical reality. Each structure reflects not only technical achievement, but also how humanity prepares for the future, from urban expansion to climate challenges. And now, let's explore the unreal mega projects that defy every limit of engineering and human imagination. Delta Works Flood Barrier System is the largest flood defense project in the world, located on the southwestern coast of the Netherlands, built to protect the country from the North Sea. It consists of 13 major structures and is recognized as one of the 7 wonders of the modern world by the American Society of Civil Engineers. Construction started in 1954 after the catastrophic flood of 1953 and was completed in 1997, taking nearly 5 decades of continuous work. Engineers faced great challenges such as weak soil, strong tides, and violent storms, which required innovations like pre-stressed concrete piles and movable barriers. Tens of thousands of workers moved over 235 million cubic yards of sand and rock, with gates rising about 33 feet that can be opened or closed depending on hydrological conditions. Today, it protects more than 3 million residents and stands as a symbol of engineering capability and human resilience. Suez Canal expansion is the enlargement of the Suez Canal, the artificial waterway linking the Mediterranean Sea with the Red Sea, reducing shipping distance between Europe and Asia. Launched in 2014 and completed by 2015 in just 1 year, the project covered about 45 miles, making it one of the fastest infrastructure achievements in the world. Its major highlight was the creation of a parallel channel that allows two-way traffic, increasing daily ship capacity from 49 to over 90. Today, it stands as a vital artery of international commerce, symbolizing both engineering achievement and the ambition of global integration. Panama Canal expansion is one of the largest infrastructure projects of the 21st century, located in Central America and connecting the world's two most important oceans. Officially completed in 2016, after almost 9 years of construction, its purpose was to double the capacity of global maritime trade. The new lock system is about 1,400 feet long, 180 feet wide, and 60 feet deep, capable of handling massive cargo ships weighing more than 200,000 tons. During construction, millions of cubic yards of earth and rock were removed, with tens of thousands of workers and engineers overcoming complex geology and harsh climate. Today, Panama Canal expansion stands as a symbol of strategic vision, global connectivity, and a new era for international commerce. Large Hadron Collider, CERN, is the largest particle accelerator in the world, buried underground along the border between Switzerland and France, designed to unlock the secrets of the universe. With a circumference of more than 17 miles and a tunnel depth of around 330 feet, it allows protons to collide at speeds close to that of light. Large Hadron Collider now stands as a symbol of human intellect and the ambition to push the frontiers of modern physics. Kansai International Airport is one of Japan's most impressive infrastructure projects, built on an artificial island in the bay, several kilometers off the mainland. Officially completed and opened in 1994, after nearly 7 years of construction, it became the world's first international airport built entirely on the sea. Kansai features a runway about 2 miles long, capable of handling the largest aircraft in service, and a terminal designed by architect Renzo Piano, stretching about 1 mile, which was the longest terminal in the world at the time of its opening. Today, Kansai stands not only as a vital air gateway for the region, but also as proof of humanity's ability to conquer the sea through knowledge and technology. International Space Station, ISS, is the largest scientific construction ever built in space, orbiting Earth at an altitude of about 250 miles at nearly 17,500 miles per hour. It was launched in 1998 and took more than 10 years to complete, involving the cooperation of dozens of nations and hundreds of scientists, engineers, and astronauts assembling it directly in orbit. The station weighs over 925,000 pounds, stretches about 358 feet long, and offers living space similar to a 5-bedroom house, accommodating 6 to 7 astronauts for extended stays. Its construction required more than 160 spacewalks under extreme conditions, where astronauts faced zero gravity and temperature swings from minus 240 Fahrenheit to above 250 Fahrenheit. Today, the International Space Station stands not only as a symbol of advanced science and engineering, but also as proof of humanity's ability to collaborate globally in the exploration of space. Hoover Dam is one of the greatest engineering achievements of the 20th century, built on the Colorado River and symbolizing how human ingenuity conquered the extremes of nature. Construction began in 1931 and finished in only 5 years, with the structure rising about 725 feet high and stretching 1,240 feet long, containing over 4 million cubic yards of concrete, enough to pave a highway across the United States. More than 21,000 workers labored under harsh desert conditions, facing summer heat that could exceed 113 degrees Fahrenheit. Scientifically, Hoover Dam was designed as a curved arch against the water flow, distributing pressure into the canyon walls, which increased stability and reduced the risk of fractures. Beyond generating power for millions, the dam also provides flood control and irrigation to millions of acres of farmland in the American West. Its completion during the Great Depression became a symbol of national resilience and proof that people can build timeless structures serving sustainable growth. Itaipu Dam is one of the largest hydroelectric projects in the world, built on the Paraná River between Brazil and Paraguay, a region that has become a true powerhouse of South America. Constructed between 1975 and 1984, with more than 40,000 workers and engineers, the project overcame immense geological and hydrological challenges. Rising 643 feet high and stretching almost 5 miles, the dam contains enough concrete and steel to build dozens of medium-sized cities. With 20 massive turbines and an installed capacity of over 14,000 milaburi, Itaipu once held the world record for annual electricity generation, supplying most of Paraguay's demand and a significant share for Brazil. The dam stands as a testament to human capability in harnessing natural forces through modern science and engineering, leaving a lasting legacy in global energy history. Golden Gate Bridge is a suspension bridge spanning the strait that connects the Pacific Ocean to San Francisco Bay, recognized as one of the most iconic infrastructures of the 20th century United States. Measuring about 9,000 feet in total length, with a main span of 4,200 feet. It was the longest suspension bridge in the world when inaugurated in 1937, rising 745 feet above the water. The towers are coated in the distinctive international orange color to ensure visibility in heavy fog. Construction lasted over 4 years, with nearly 4,000 workers involved, facing challenges such as strong currents and high winds. Around 660,000 short tons of steel and concrete were used, enabling the structure to withstand earthquakes and storms. Today, Golden Gate Bridge stands not only as a vital transportation link, but also as a global symbol of the union between technology and landscape. CN Tower is a landmark of Canada, located in Toronto near Lake Ontario, and it is considered one of the world's most remarkable telecommunication and tourism structures. Standing 553 meters tall, the tower once held the record as the tallest structure on Earth for 32 consecutive years after its completion in 1976. Construction lasted 40 months, employing more than 1,500 workers who faced strong winds and unstable ground conditions. More than just an engineering feat, it stands as a national pride, symbolizing how human ingenuity and science can overcome the challenges of nature. Öresund Bridge is the iconic structure crossing the Öresund Strait, linking Sweden and Denmark and serving as the most vital transport route in Northern Europe. The bridge stretches about 5 miles and continues into a tunnel of 2 miles, forming the only large-scale bridge tunnel system of its kind in the world. Completed in 2000, after nearly 5 years of construction, it involved more than 2,000 engineers and workers. The central pylon rises to 670 feet, while the navigation span of 1,600 feet allows massive ships to pass freely. More than 1.3 million cubic yards of concrete and around 88,000 tons of steel were used, assembled with precision by floating cranes and barges. Today, Öresund Bridge is not only an engineering milestone, but also a symbol of how modern science and technology unite nations. Petronas Twin Towers. Located in the capital of Malaysia, the Petronas Twin Towers stand as an iconic landmark of Southeast Asia and once held the record as the tallest twin towers in the world. Rising to 1,480 feet, with 88 floors made of steel and reflective glass, the towers were completed in 1998 after 6 years of continuous construction. Engineers faced major challenges due to the soft ground, requiring nearly 13 million hours of labor and foundations dug about 390 feet deep, among the deepest ever built for skyscrapers. Construction required over 210,000 cubic yards of concrete and nearly 73,000 pounds of reinforcing steel, showing the massive scale of the project. Today, the Petronas Twin Towers remain a testament to engineering vision and creative strength of the 20th century, attracting millions of visitors worldwide. Lotte World Tower. Rising in the heart of Seoul, Lotte World Tower stands as the tallest building in South Korea and one of the top 5 tallest skyscrapers in the world at the time of its completion in 2016. Reaching a height of 1820 feet with 123 floors, the tower required 6 years of construction, more than 13,000 workers and engineers, and millions of tons of steel and concrete to ensure structural stability against earthquakes and typhoons. Its glass facade was scientifically designed to reduce wind pressure, improve energy efficiency, and create a sleek, modern appearance. The building is both a symbol of modern engineering and a reflection of South Korea's ambition to reach the global stage. Incheon International Airport is the largest air gateway of South Korea, located on an island off the west coast of Seoul and recognized as a strategic aviation hub in East Asia. Officially opened in 2001, after nearly 8 years of construction, involving tens of thousands of engineers and workers, it stands among the largest airports in the world, with an area of about 21 square miles. More than a transportation hub, Incheon International Airport stands as a symbol of South Korea's modernization and strategic vision. Channel Tunnel, Eurotunnel, is recognized as one of the most impressive underground transport projects in the world, linking Britain and France beneath the English Channel with a total length of about 31 miles. It is the longest undersea tunnel on Earth, with the submerged portion stretching nearly 24 miles, completed in 1994 after more than 6 years of construction. Channel Tunnel is not only a symbol of engineering excellence, but also a testament to international cooperation, creating a safe and sustainable transport corridor between two nations. Milo Viaduct. The Milo Viaduct is one of the tallest cable-stayed bridges in the world, crossing the Tarn Valley in southern France where the rugged terrain once posed major challenges for transportation. Officially opened in 2004, the bridge quickly became a symbol of modern engineering, reaching a record with its tallest pylon, standing 1,125 feet, higher than the Eiffel Tower. During its 3 years of construction, more than 2,500 workers and engineers participated, using around 79,000 pounds of steel and a volume of concrete comparable to that required for a small town. One of the greatest difficulties was the frequent strong winds on the plateau, which forced engineers to design the cable system and steel deck to withstand gusts up to 125 miles per hour. The bridge stretches nearly 1.5 miles with 7 main pylons, each weighing tens of thousands of tons and precisely anchored into solid rock to ensure long-term stability. Scientists consider the structure a prime example of the combination of optimal geometry, advanced materials, and precision assembly at unprecedented heights. The Millau Viaduct not only shortens travel between major European regions, but also stands as proof of humanity's ability to overcome natural challenges with intellect and technology. Palm Jumeirah is a world-renowned artificial palm-shaped island off the coast of Dubai, considered a symbol of modern offshore engineering. Construction began in 2001 and was completed in 2006, creating an area of about 2 square miles, large enough to be visible from space. To build Palm Jumeirah, engineers used over 120 million cubic yards of sand and 7.7 million tons of rock, with no concrete or steel in the main structure, a solution regarded as a scientific marvel. The project faced challenges such as strong sea currents, erosion risks, and environmental balance, requiring hydraulic technology and 3D simulations to refine the design. With its distinctive shape, consisting of a 2.5-mile trunk and 16 fronds, Palm Jumeirah became home to luxury hotels and resorts, significantly expanding Dubai's coastline. Holding the record as the world's largest man-made island at the time of completion, it showcases human ambition and engineering brilliance. The island stands not only as a tourist wonder, but also as clear evidence of ambition, technique, and human ingenuity. Marina Bay Sands is one of the most iconic landmarks in Singapore, regarded as a modern symbol of global architecture and tourism. Located in the heart of the city, the complex consists of 3 towers rising 656 feet, linked by a massive rooftop structure shaped like a ship called the Sky Park. Completed in 2010, Marina Bay Sands set several records, including the world's highest outdoor infinity pool, measuring over 492 feet, attracting millions of visitors every year. Its construction took around 5 years, involving more than 7,000 workers and hundreds of international engineers, consuming enormous amounts of steel, glass, and concrete. The greatest challenge was lifting and placing the Sky Park, weighing nearly 7,000 tons, on top of the 3 towers, a task requiring absolute precision. Scientifically, the project was designed with deep foundation systems to ensure stability on reclaimed coastal land, showcasing the integration of advanced engineering with complex natural conditions. Today, Marina Bay Sands is not only a luxury hotel, but also a leading hub for conferences, commerce, and entertainment, symbolizing the ambition of the city. Abraj Al Bait Clock Tower is one of the most remarkable skyscrapers in the world, located at the heart of the holy city of Saudi Arabia. Rising to about 1972 feet, with 120 floors, it holds the record as the tallest clock tower on Earth and features the world's largest clock face, measuring more than 141 feet in diameter, visible from dozens of miles away. Completed in 2012, after nearly 8 years of construction, the project engaged tens of thousands of engineers and workers from various countries. Today, the Abraj Al Bait Clock Tower stands both as a guiding landmark and as a symbol of the balance between tradition and technology in contemporary architecture. Lahti Center is the tallest skyscraper in Europe, located on the coast of the Gulf of Finland in St. Petersburg, Russia, where modern architecture meets the vast maritime landscape. With a height of 462 meters and 87 floors, the tower holds several records, including the tallest twisted skyscraper in the world. Construction began in 2012 and was completed in 2019 after 7 years of continuous work involving more than 20,000 workers and engineers from many countries. The project faced severe challenges such as water-saturated soil, freezing climate, and special requirements for materials that could withstand extreme temperature fluctuations. Today, Lahti Center stands not only as an architectural icon of Russia, but also as a testament to human ability to conquer construction limits under harsh conditions. Burj Khalifa. Rising from the desert and the Persian Gulf, Burj Khalifa stands as the tallest building in the world and an unmistakable symbol of modern engineering. Completed in 2010, it reaches about 2,917 feet in height, surpassing all previous records and redefining global architecture. Construction lasted 6 years, involving more than 12,000 workers and engineers, with about 430,000 cubic yards of concrete and nearly 86 million pounds of steel. One of the greatest challenges was the strong winds at high altitude, which required engineers to design a Y-shaped floor plan that minimized sway and distributed pressure. With a total floor area of over 3.2 million square feet, the tower houses offices, residences, hotels, and an observation deck at more than 1,640 feet, offering sweeping views of the desert and skyline. More than a building, Burj Khalifa is a testament to human ability to push the limits of architecture and engineering. Shanghai Tower. Shanghai Tower is the tallest building in China and the second tallest in the world, rising to about 632 meters or 2,073 feet. Completed in 2015, after 7 years of construction, it has 128 floors with a spiraling design that reduces wind load by up to 24% compared to conventional towers. With over 380,000 square meters, or 4 million square feet of usable space, the tower hosts offices, hotels, convention centers, and large exhibition areas. One of its highlights is an ultra-fast elevator that moves at nearly 20 meters per second or 45 miles per hour, reaching the observation deck in less than 1 minute. With its iconic design and advanced technology, Shanghai Tower stands as proof of China's engineering achievements and urban vision in the 21st century. Beijing Daxing International Airport is one of the largest and most modern airports in the world. Opened in 2019 with an impressive starfish-inspired design. The airport covers a total area of about 7,000 square feet, designed to handle up to 72 million passengers annually. Its runway system includes 4 runways each over 12,467 feet long, allowing simultaneous operations of multiple large aircraft. The terminal layout is optimized so passengers can walk from the security checkpoint to the farthest boarding gate in about 8 minutes. Multimodal transport connections, including high-speed rail, metro, and expressways, are seamlessly integrated, making it a strategic air gateway for the region. Donghai Bridge is one of the longest cross-sea bridges in the world, linking the mainland with an offshore island to form a vital transportation route serving both cargo transport and economic development along China's eastern coast. With a total length of about 20 miles, the bridge is designed to withstand strong winds and high waves of the East China Sea while maintaining stable traffic year-round. The deck is 102 feet wide, allowing multiple lanes of vehicles to move simultaneously, meeting the heavy transport volume between the seaport and the mainland. Its structure uses high-strength steel and special salt-resistant concrete, ensuring long operational life in a harsh marine environment. From the bridge, visitors can view the vast sea stretching to the horizon, where streams of vehicles move continuously like a flowing link between land and open waters. Danyang Kunshan Grand Bridge is the longest bridge in the world, stretching approximately 102 miles, serving as a vital artery of the Beijing-Shanghai high-speed railway and efficiently connecting major economic centers. Completed in 2010, after 4 years of construction involving thousands of engineers and workers, it showcases remarkable organizational and engineering capabilities. The bridge's structure, primarily made of reinforced concrete, is designed to withstand earthquakes of up to magnitude 8 and strong wind conditions, ensuring long-term operational safety. Beyond its transportation role, Danyang Kunshan Grand Bridge stands as a symbol of modern infrastructure capability, internationally recognized as a world-leading engineering achievement. Yinping-I Hydropower Station is one of the largest hydropower projects in the world, built on the Yailong River to provide stable electricity and support flood control for a vast region in southwestern China. The dam stands about 305 meters tall, equal to a skyscraper over 100 stories high, creating a massive reservoir that regulates river flow and supplies water for production activities. From above, Jinpingmi appears as a colossal curved wall embracing the river, blending the power of technology with the grandeur of nature. Jiushan Islands Link Project is a vast sea-crossing bridge system stretching over 48 kilometers, connecting the mainland of Zhejiang Province with the Jiushan Archipelago, playing a pivotal role in China's maritime economic development. With its scale and impact, Jiushan Islands Link Project is regarded as one of the most modern and impressive sea-crossing bridge systems in the world. Jiaozhou Bai Bridge is one of the longest sea-crossing bridges in the world, linking Qingdao City with the Huangdao area, reducing the travel distance by more than 19 miles compared to the traditional coastal route around the bay. The bridge has a total length of about 26 miles, with its main span stretching 16 miles across the water, built with reinforced concrete structures designed to withstand strong winds and powerful ocean waves. Its deck is wide enough for 6 traffic lanes with a speed limit of 50 mph, meeting the growing demands for cargo and passenger transportation. The bridge piers are optimally engineered to minimize environmental impact while enduring major earthquakes and saltwater corrosion. Jiaozhou Bay Bridge not only shortens distances, but also links key economic areas, contributing to trade, tourism, and urban development across the coastal region. Baihetan Hydropower Station is one of the largest hydropower projects in the world, located on the mighty Jinsha River, playing a vital role in China's power network. The project features a concrete arch dam about 289 meters high, equivalent to a 95-story building with a base width of over 72 meters, capable of withstanding immense water pressure. It has 16 Francis turbine generator units, each with a capacity of 1,000 millibar, bringing the total installed capacity to 16,000 millibar, enough to supply electricity to tens of millions of households annually. The reservoir holds over 20 billion cubic meters of water, creating a vast water body that regulates floods and ensures a stable supply for downstream areas. From above, the entire facility appears like a giant machine fused into the mountainous landscape, blending with nature while demonstrating human capability in harnessing water for sustainable development. Jinping-I Hydropower Station is one of the largest hydropower projects in the world, built on the Yailong River to provide stable electricity and support flood control for a vast region in southwestern China. The dam stands about 305 meters tall, equal to a skyscraper over 100 stories high, creating a massive reservoir that regulates river flow and supplies water for production activities. Its double curvature concrete arch structure is engineered to withstand immense water pressure in the narrow, mountainous terrain. From above, Jinpingmi appears as a colossal curved wall embracing the river, blending the power of technology with the grandeur of nature. Fuyuhi Bridge is one of the highest suspension bridges in the world, spanning the Siduhe Valley with a height of about 496 meters from the deck to the riverbed. Completed in 2009, it serves as a vital link on the expressway between Shanghai and Chongqing, significantly reducing travel time across the rugged, mountainous terrain. The bridge has a total length of about 12,022 meters, with a main span of 900 meters, allowing vehicles to cross the vast gap of the valley in just a few dozen seconds. Its design combines load-bearing steel structures with a meticulously calculated cable suspension system to withstand strong winds and earthquakes, ensuring year-round traffic safety. Siduhe Bridge is not only an engineering marvel, but also a symbol of human ingenuity and creativity in conquering harsh terrain. Pingtang Bridge is one of the tallest and most impressive bridges in the world, spanning a deep valley in Guizhou Province, China, with its main tower reaching approximately 1090 feet, equal to a building of over 100 floors. This structure is a vital part of the expressway linking economic hubs in the region, significantly reducing travel time and expanding trade opportunities. The bridge has a total length of about 7,020 feet, using a unique three-tower cable-stayed design, engineered to withstand strong winds and the complex, mountainous terrain. Building Pingtang Bridge required high-precision construction techniques, as engineers had to install massive cable stays and steel deck segments at great heights while ensuring absolute safety. The combination of advanced engineering and untouched natural landscapes has turned Pingtang Bridge into a new icon of China's transport infrastructure. Longjiang Bridge is a modern suspension bridge spanning a deep valley, inaugurated in 2016, serving as a key link in the transportation network of northwestern Yunnan Province. With a total length of about 805 meters and a height of approximately 280 meters from the deck to the valley floor, it is among the highest bridges in the world, allowing vehicles to cross rugged terrain without detouring through winding mountain roads. This bridge not only boosts the regional economy, but also demonstrates the ability to conquer complex terrain with advanced engineering solutions.